This is video part 2 for resistors connected in series. But before starting, can you tell me the key takeaway points from the previous video?
Yes. When resistors are connected in series, the current remains the same. But the voltages add up.
Good. And now it's time to do the derivation. We have to bring Ohm's law here. You remember Ohm's law?
Yes. Ohm's law states that current flowing through a conductor is directly proportional to the voltage across the 2 points, and it is inversely proportional to the resistance of the circuit.
That's right. So in other words, we can say that I is equal to V by R, where I is the current, V is the voltage and R is the resistance. So R will be equal to V over I, and V will be equal to I times R. So this is what Ohm's law is. An easy way to remember this is by using the VIR triangle. R. So I will be equal to V over R will be equal to V over I, and V will be IR. Can you draw a circuit showing 3 resistors connected in series?
Sure.
So, if V is the total voltage provided by the battery, then the voltage in the individual resistors will be V1, V2 and V3. Similarly, if total current in the circuit is say I, then in the individual resistor it will be I1, I2 and I3. So Ohm's law can be applied to all the individual resistors, and Ohm's law says V is equal to IR. This can be applied to all these 3. So for resistor R1, it will be V1 is equal to I1 R1. For the second resistor R2, it will be V2 equals to I2 R2, and for resistor 3, it will be V3 equals to I3 R3. Okay, so as I said, Ohm's law can be applied to any individual resistor. And we know that Ohm's law is V is equal to IR. Now, this V can be substituted for all. So, here V will be IR, which will be equal to, for resistor 1, it will be I1 R1 plus, for resistor 2, it will be I2 R2, and for resistor 3, it will be I3 R3. So here I1, I2 and I3 is same as the main current that is flowing, which is I. So in this case, to make the equation balance on both sides, we can take the I's out. So what is left with? R will be equal to R1 plus R2 plus R3. This is the final equation for resistors connected in series. So R is the total resistance, which is equal to resistance in the first resistor plus the second resistor and the third resistor.
As you all have read the question, let's solve it. It is essential to draw what's given in the question, so I'll start with the diagram. R1 is 6 ohms, R2 is 7 ohms, R3 is 8 ohms. This is given in our question. Now the formula is to find total resistance is R1 plus R2 plus R3. We know the values for R1, R2 and R3. We can just fill it in here. The total will be 21 ohms.
Okay, let's solve this problem. There are three resistors connected in series. R1 is 4 ohms, R2 is 5 ohms, and R3 is 6 ohms. Now what we have to find here is three things we need to find. One, total resistance, that is R, the total resistance in these three resistors. Second thing we need to find out is the current, the amount of current that's flowing in this circuit. And the third thing is the voltage drop, that is the total voltage has been given, which is being provided by the battery here, and we have to find out the voltage drop in R1, voltage drop in R2 and voltage drop in R3. So let's see. We start with number 1. And remember the formula of the total resistance, that is R is equal to R1 plus R2 plus R3. So we plug in the value here. So the total resistance R will be R1 is 4, R2 is 5 and R3 is 6, which is equal to 4 plus 5 plus 6 is 15 ohms. So we got our first answer, that is total resistance. Now let's look at the second one, that is current I. And then you know Ohm's law says V is equal to IR. So I will be equal to V over R. Again, let's plug in the information. So I will be equal to V has been provided, which is 30 over R we just calculated, that is 15 ohms. So 30 divided by 15 will give you 2, and the unit for current is amperes. So 2 amperes is the answer for number 2. And now the third one we need to find out is the voltage drop among the three resistors. And now that we know R is equal to 15 ohms, I is equal to 2 ohms, we need to find out the voltage drop in all three resistors. So how do we do it? V1, V is equal to IR. So we have to find the voltage drop V1, V2 and V3. So V1 will be equal to I1 R1, which is I will be same for all, which is we just calculated 2 ampere. So 2 times R1 is 4. So 2 times 4 is 8. Similarly, for V2, it will be again the current will be the same 2 ampere, and this is 5 ohm resistor. So 2 times 5 is 10. And for resistor number 3, that is V3, will be equal to again 2 will remain the same, and then 6, which is 12 volt. So these are the voltage drop in resistor 1, resistor 2 and resistor 3. So the total voltage drop has to be equal to the total voltage provided initially by the battery. So V will be equal to V1 plus V2 plus V3. So by plugging in the value we get 8 plus 10 plus 12, that is equal to 30 volt, and this 30 volt is what we started with. So that's how you calculate the voltage drop.